Hello students, welcome back. Let's resume our discussion on CDF, the cumulative distribution functions. Here's the definition. Capital F of x is the probability that the random variable is taking x or less. Okay? The random variable is taking a value of small x or less. Whereas, here's a definition of the probability mass function. The probability that the random variable is taking a real value precisely equal to x. So just equals to x here, equals to x or less. Now here we have equation. Here we have an inequality. Which is easier, equality or inequality? Equalities are easier. So probability mass functions were easier. Cumulative distribution functions, on the other hand, that was a bit tougher. We went through the first example. Now let's go to the second example. Because we already went through the first example, let me go a little bit more quickly here. So we are taking these three values, and here is the probability mass function. Remember? It is possible to take negative 1.5, 0.5, or 1.5. And those probabilities are RGB, 5/10, 3/10, 2/10 respectively, otherwise all 0. And then here is a graph, by the way. At negative 1.5, 0.5, 1.5, we have probabilities like these, otherwise all 0. Okay, from here, let's copy and paste this thing. Now, let's get cumulative distribution function. No, let's do it this way. Okay, let's consider cumulative distribution function. All right, we have x values of negative 1.5, 0.5, or 1.5. And these three numbers divide the number line into 4 pieces. First, less than negative 1.5. So this one. Okay. Okay. There, probability is, cumulative probability is 0. I want to remove all those colors here. And then let's restart. Now next number is 0.5. So between negative 1.5 and 0.5. So negative 1.5, x 0.5. Remember, same inequality to the left, strict inequality to the right. And here, I have to add the first probability. Never mind. I'm not going to worry about any of those colors. Okay, next. 0.5 to 1.5. Same inequality to the left, strictly inequality to the right. And then I have to keep accumulating, right? We were up to here. Plus 3/10. And then 1.5 to next. And then I have to keep adding up. That's what I get, right? Okay, let's simplify. Here, it's all done, all right? Here, this is 5/10. Okay, all right. Here, it is 8/10. And then everything was added up, so we have 1. And I guess the final expression down here completed the problem. What do you think? From the same table from the PMF, if we have these 3 numbers and 1 more column for otherwise, we have precise match for the CDF. 3 plus 1, and the 3 numbers divide the number line into 4 pieces. So I need 4 columns here. So these 4 will do. And first, less than -1.5. Between these two, -1.5 to 0. And between these two, 0.5 to 1.5. And finally, 1.5 to infinity. And at each place, semi-inequality to the left, strict inequality to the right. Of course, here, I cannot use semi-inequality to the left because this is negative infinity. No number is equal to negative infinity. So this is how you can get the CDF in action. A little better forms are here. And also, you can use the vertical tabular expression as well. Here, I'm showing you all those accumulations. And then here, after everything was accumulated and added in. And here I kept with 5/10 and 8/10, but probably a lot of students would prefer to rewrite those as 0.5 and 0.8. And then finally, we have the piecewise defined function expression. Essentially the same as this final vertical tabular expression, but somehow students feel intimidated whenever they see something like this, but there's no reason to be intimidated. It's exactly the same as this vertical tabular expression, which is in turn the same as this horizontal tabular expression. Nothing to be intimidated. And as for the graph, it's a step graph, as always. We have -1.5, 0.5, 1.5, and those are the jump locations. -1.5, 0.5, and 1.5. And then what's the jump size? Those are probabilities. How many red balls, green balls, and blue balls? 5/10, 3/10, 2/10. That's how you get the graph. As for the third problem, well, left to the students. Go ahead, what do you get? Probability mass function like this. Just 2 values, -1.25, 4.75, otherwise 0. So these 3 columns will be necessary because I want less than -1.25, between these 2 numbers, -1.5 to 4.75, and then greater than 4.75, like this. This, and then after all the accumulation, like that. And finally, here's the graph. We have 2 jumps. Okay, let's see. We did some examples of PMF to CDF, as a matter of fact. Let's do one more time. Find the cumulative distribution function, CDF, of the given probability mass function. Okay, all right. This is a copy of probability mass function, PMF. So let's go to cumulative distribution function. So let's go to capital F. And then numbers are 0.5, 1.25, 1.75, 2.0. So we start from less than 0.5. And then like this. And always begin from 0 because nothing was added. Now between 0.5 to that, what's happening here? Oh, I see. I made some mistake here. I want to change the text color, ended up changing the background color. All right. I got up to here. Now 1.25 to 1.75. And then 1.75 to 2.00, and finally 2.00 to infinity. And always begin from 0 and end as 1 after everything accumulated. Now let's come here. At x equals to 0.5, 1/4 is being added up. So 0 plus 1/4, which is 1/4. Next, 1/8 is being accumulated in. So previously 1/4 plus 1/8, and that results in what? 3/8. Now another 1/8 is being added up. So 3/8 plus 1/8, which is 4/8. So same as 1/2. And there, another 1/2 is added up. Do we get 1? Yes, indeed. So there goes my CDF. If you have PMF, getting CDF is easy. You have exact match of the number of columns, as a matter of fact. So with copy and pasting with this Mathematica, I can do it really effectively. But if you have to use just paper and pencil, again, use the same column. If you have 4 numbers here, these 4 numbers, divide the number lines in 5 pieces, so you need 5 columns. This otherwise 0 is actually making some good service here. Let's see. Okay, here in the solution, I have appropriate color coding as well. And then here is a graph associated to that. Okay, all right. And then we can find out the cumulative distribution function this way. So 0.5, 1.25, 1.75, 2.0, they are all here in this number line, not up to scale. And these 4 numbers divide the real number line in 5 pieces. Class interval number 1, number 2, number 3, number 4, and number 5. And the structure is semi-inequality to the left, strict inequality to the right, always. So that if you have precisely 1.25, you belong to one higher interval. All right? Just like if you score precisely 80 in this class, you belong to one higher class interval. You scored B. All right? And then begin from 0. You just keep accumulating. Add 1/4, and then add 1/8, and then add 1/8, and then finally add 1/2. Eventually you get that. And here's the graph. Okay, good. In the next video, we're going to discuss going backward from CDF to PMF.